And I'm recording again. All right. So this, oh wait, sorry. Let me start at the beginning. Here we go. Okay. So in P3, what we actually deal with are polynomials. So basically in P3, we're going to see what we first see what a polynomial is. Okay. Then after that, what we're going to see is how you add and subtract them. And we'll see how to multiply them. In fact, with multiplying especially, I'm actually going to show you two methods for multiplying. One of them, I'm going to show you two methods actually. One of them is more visual than the other. And I like to show both methods mostly because some people like to see things more visual than, some people are more visual than others. So I figured by showing both methods, that would help address the different learning styles. Whatever method you decide to use, that's up to you. So before we get to polynomials, first we have to consider monomials. So by definition, so there is a lot of terminology here, and let me just go through it. A monomial, by definition, in the variable x, it's a term that looks like this. It's a times x raised to the k. So x is a variable. A is a constant. So it could be a number like 1, 2, -4, whatever. A is a constant. We call it a coefficient, the coefficient. K, this exponent, this is a non-negative integer. Now, if a, though, the coefficient is not 0, then k, the exponent of x, that's called the degree of the monomial, if a is not 0. So if a is not 0, the k here is the degree of the monomial. Now, with that, if you have only a non-zero constant, so in other words, you have your a, but you don't have any x's here, then we say it's a monomial of degree 0, assuming a is not 0, though. So a non-zero constant alone, like 1, 4, 8, whatever, there's no variable, we say it has degree 0. I mean, what I threw in here is not really precise. That's why I'm using quotation marks here. You could think of x to the 0 as being 1. You know, before we just saw that a to the 0 is 1, right? Although it's not that precise, mostly because if x is 0, then this is not going to make sense. You know, x is a variable. Now, if the a in front, right, if this is 0, the monomial you get is just 0, excuse me, and that has no degree by definition. So basically, if the a, the coefficient, is not 0, the exponent of x is the degree of the monomial. And if there's no variables there, then the degree is just 0. But if the whole thing is 0, if a itself is 0, right, then there is no degree. That's part of the definition. I'm not sure why they define it that way. I think I saw it once when I was in grad school, but I don't remember exactly why. So, but that's okay for now. All right. Good. Okay. All right. So I know that's a bit much. Let's do some examples. So for instance, let's suppose, oh wait, I forgot well, we'll see it here actually. 3 times x, right? Remember, if the exponent is 1, we don't write the exponent. You know, we saw that already today. So 3 times x is a monomial. Okay? The degree of this thing is 1 because the power of x, the exponent of x, is 1. Again, the exponent's 1, we don't write it. The coefficient is 3. The coefficient is 3. 5, there's no x here, right? We just have 5. 5 is not 0. A non-zero constant is a monomial of degree 0. So 5 alone is a monomial of degree 0. X alone is a monomial. The coefficient, it looks like it's not there, but if the coefficient is 1, we don't write it. That's actually what I forgot to say on the previous slide. I said it for the other class, but I forgot to say it here. But if the coefficient is 1, we don't write it. I mean, it's not really wrong to write it. It's just something that people don't do, I guess, for convenience. So if you have x alone here, right, this is the same as 1 times x to the first. So the coefficient is 1. The exponent of x is also 1. So this is a monomial of degree 1. Okay. So that's what monomials. Are there any questions about this? Because I know the terminology is a little weird. It does take some getting used to. Okay. Now, with monomials, before we get to polynomials, we have to consider how you add and subtract monomials. Basically, we have two monomials in the same variable with the same degree. Those monomials are called like terms. So two monomials are called like terms if they're in the same variable and they're of the same degree. That's just by definition. They're called like terms. And if they're not like terms, we call them unlike terms. So going back to this one, x and 3x are like terms. They're both in the same variable, and they both have degree 1. Whereas 5 and x are not like terms. 5 has degree 0, x has degree 1. And now why do we care about that? Well, we can add and subtract. That is, we can combine monomials together, but we only combine like terms. So we can only combine them, that is, we can only add and subtract them if they are like terms. These equations are telling us how to do that. This is not factoring, okay? Someone in the other class, I think, thought it was, but it's not factoring, though. What I'm trying to show you here is if you have two monomials that are like terms, when you add them by just adding the coefficients. That's what I'm trying to show you here. When you subtract two monomials that are like terms, you only subtract the coefficients. Notice also that the exponent, the degree, does not change. In other words, you don't change the power, the exponent of x. I've seen students in the past, when they combine these, they would say they would write 2 times m as the exponent. In other words, I've seen students add or subtract the exponents, but don't do that. When you add or subtract monomials, you don't change the exponents of x, of the variable. And just to illustrate some examples, suppose we have x and 4x. Well, as I already said, x alone is a monomial of degree 1. Its coefficient is 1. Remember, if the coefficient's 1, we don't write it, but we have 1x. 4x is a monomial of also degree 1, right? So they both have degree 1. They're both in the variable x, same variable. So these are like terms. X and 4x are like terms. How do we add them? We add the coefficients, 1 and 4. We have 1 plus 4x, which is 5x. So we have 1 plus 4x, which is 5x. Now, what if you had, though, 1 plus 5x? Well, these are not like terms, right? This is degree 0. This has degree 1, right? There's no variable here, but there's a variable here. So we can't combine those. We just leave it alone. We leave them alone. What about here? Well, here we have this monomial, 2x cubed, we have 10x cubed, and we have 5x squared. Well, are there like terms here at all? Well, yeah. 2x cubed and 10x cubed, those are like terms. They're both monomials of degree 3 in the same variable. So 2x cubed and 10x cubed, we can combine. We can subtract them. How do we do that? We subtract the the coefficients. 2x cubed minus 10x cubed, right? This is 2 minus 10x cubed, which is minus 8 cubed. The 5x squared is still there, but notice we cannot combine it with anything, right? 5x squared and negative 8x cubed, they're not like terms. Their degrees are different. This is degree 3, this is degree 2, so we can't combine those. We just leave them alone. We just leave them alone. They're not like terms, they're unlike terms. Okay, that's fun. Then what? Well, now we're ready to define polynomials. Are there any questions on this though? Any questions on this? Okay. A polynomial is basically in the variable x is just a sum of monomials in the variable x. I really should say finite sum. Although infinite sums, you don't see that till calculus. So you're basically just adding some monomials together. That's what a polynomial in the variable x is. And it turns out you can always write it in this form, where if you read it from left to right, the powers of x are decreasing. Excuse me, the exponents of x are decreasing. And the first term here, the coefficient is not 0. In fact, the biggest exponent of x, that's the degree of the monomial. That's what the degree of the monomial is, okay? So, well, we're out of time, actually. It's 1:50, so let me stop.